another tutorial. Today we are going to create some procedural pasta in Blender with Geometrynodes. We start with our default cube. I have already added a Geometrynodes modifier. I'm starting with a curved spiral, connecting this to the output, and I'm removing the geometry input. I'm starting to connect the height parameter of our curved spiral to the group input. And I'm setting the start and end radius to a quite low value, so we have a slightly twisted base geometry. We will use the start and end radius later to give our pasta some random twist. I'm connecting the rotations to the group input so we can control it through the modifier. The minimum amount of rotations cannot be 0, so I'm setting it to a quite low value. Now it is time to move our pasta to the center. For this I'm using the set position node. To center it, you need to move it down by half of the length of the pasta. For this I am dividing the length by -2, and I use a combine XYZ node to create a new offset vector. And now our curve is always centered, no matter how long it is. And now it is time to create our curve profile. I am using a curve line for this. First I'm adding a new input parameter, and I'm calling this one radius. And I'm using a combine XYZ node to create a new vector. I scale the vector by -1 to define the start point and use the base vector as an endpoint. Now we add a curve to mesh node and apply our curve profile. I want my pasta to be a bit thinner at the top and bottom end. Let's add a curve radius node to control the curve radius. I want to control the radius of our spline through the spline factor. And I am using a float curve to define a profile along our spline. This already looks much better. I am adding some random noise to our curve radius to give our pasta some slight distortion. Now it is time to set the tilt of our curve to give it the twisted look. Let's add a Z tilt node. And then we will use our spline factor again. And we have to multiply our spline factor by 2 times pi to get one full rotation along the spline factor. And then we will multiply this again by a new value. And we connect this value to our group input and we call it twists. Now it is time to give our pasta some thickness. First I am setting the shading to smooth. And now let's add an extrude node. And let's connect the offset scale to our group input. And now we can control the thickness of our pasta through our modifier. We need to add another extrude mesh node to extrude our mesh into the opposite direction. For this we need to flip the faces first. And we will connect the input parameter for the offset scale for this one too. Then we have to join both meshes. Check the normals. And then we add a merge by distance node. Finally, some subdivision. And we will connect the subdivision level to our group input. And that's it. Now we have some procedural pasta. Let's add a material. I have already prepared one. Beautiful. And now we can create copies of our object and tweak the parameters to get different shapes. I am connecting the start and end radius to the group input too, so I have more tweaking options for my pasta. And that's it for this video. You can get the whole setup, including the pasta planet with the meatball moon, on my Gumroad account, or you download it for free from the video description. Bye!